So if you think about a spring, we talked about before how the spring wants to go to neutral. So we have like some kind of a neutral line here. And that the force on the spring, or the force of a spring on a box, was always trying to get it back to neutral. So if we were here, it was trying to get it back this way. And if we were here, it was trying to get it back this way. Okay? And that there was some kind of spring constant, K, and that the force could be determined by the force given by the spring constant times the distance away that it is from neutral. Okay, so think about this. What is the work done by the spring going from that position to neutral? Okay, so remember our definition of work is integral F dot dr. Well, in our case, F is entirely, say, in the, what do you call it, x direction. So kx, it's going in the positive direction, 0, 0. And then the dx is dx, dy, dz. So if I dot that, I get kx dx. Now your book is going with negative kx dx, and that's fine because it's the way they're defining it. How about this? Whenever I was an undergrad, I could never remember whether it was supposed to be positive or negative, and I would always get it wrong because I was always guessing and I didn't understand what was going on. So I'm doing it sign neutral, and then I want you to look at the picture and see what's actually happening so that you can figure out whether or not the work is positive or negative. So let me show you. So the work done by a spring, do you see if so this k is constant, right? So if I have integral x dx, that's just going to be k over 2 x squared, and it's going to be evaluated from something to something, you know, whatever those endpoints on the integrals are. But 1/2 kx squared. So you may or may not have already had a class where you learned that the work done by a spring is something like 1/2 ks squared, or you might have seen this done as the potential energy of a spring, because that's where we're going with this. But basically the idea is from one place to another. So what you want to do is, if you want to find the work done by a spring, it's going to be 1/2 times k, and then s of one of the points squared minus s of the other point squared. So like here, this distance is 0, or not 0, let's just pretend this distance is 5. So I would always get confused as a student as like, does the 5 go here or does the 5 go here? Because depending on where you put it, you'll be off by a negative. So let me just give it to you straight. It's a distance of 5. One of them is going to be 0. The other one is 5. So you've got 25 ks squared, or k over 2. Now you look at the picture. What kind of work is being done on that spring? Is that spring successful? In this case, yes, the spring is successful. Awesome. So that's positive. Does that make any sense? So I ran into all kinds of problems before not knowing what was going on. So for example, here, if this is again x equals, x equals 4, then, oh, that's going to be a weird number. Let's go with x equals 10. Then the work done by this spring in going from position 1 to position 2 is 1/2 k, and then the difference between the x squareds, well, one of them is 0, the other one is 100. Now, is it being successful or unsuccessful? Well, it's successful, so it's positive. So that means that the work done by that spring is 50k. Now, on the flip side, let's pretend that I go from here to here, and x equals, I don't know, 8. Okay, so the change in distance is 1/2 k, and then 0 squared minus 8 squared, so 64. Okay, but is the spring being successful? No, the spring sucks at its job, so it's doing negative work. Okay, Does that make sense? Okay, because I would get confused because of all kinds of reasons. So if you like the way the book is doing it, great. If you're like, I keep getting it off by a negative and I don't know why, then stop looking at formulas and just start trying to understand what's actually going on in the system. And if the spring is doing bad at its job, then it's doing negative work. And if it's doing great at its job, then it's doing positive work. But the kind of work it's doing is this 1/2 ks squared work.